Each year, the Thayer School of Engineering recognizes a graduate or friend of the Thayer School with the Robert Fletcher Award, given in recognition of distinguished achievement and service in the highest tradition of this 149-year-old school. When Robert Fletcher was selected by General Sylvanus Thayer and Dartmouth President Asa Dodge Smith to become Thayer School's first professor and dean in 1870, he was a 23-year-old Army lieutenant serving as an assistant professor of mathematics at the U.S. Military Academy. Over the ensuing 65 years of service to Thayer and the community, a record I suspect that will never be broken, Fletcher left a strong, lasting impression on generations of students. For students, his accomplishments as director and teacher almost invariably merged with his quality as a human being. As we say that Sylvanus Thayer was the father of the U.S. Military Academy, so was Robert Fletcher the father of the Thayer School of Engineering. In addition to leading the engineering school, Fletcher designed and supervised construction of steel bridges across the Connecticut and White Rivers and waterworks for the towns of Hanover and Enfield, New Hampshire. For more than 40 years, he was president and chief engineer of the Hanover Water Company. His many activities contributed importantly to the early prestige of Thayer School, the betterment of his community, and the advancement of education in engineering nationwide. The individual selected to receive Thayer School's Robert Fletcher Award must possess the qualities exemplified in the life and work of this remarkable individual. This year, we are honored and proud to present the 2016 Robert Fletcher Award to Dr. Arati Prabhakar. Arati Prabhakar is the director of the Defense Advanced Research Projects Agency known as DARPA. Serving in this position since 2012, she has focused the agency on rethinking complex military systems, harnessing the information explosion to improve national security, and spurring advances in fields ranging from synthetic biology to neurotechnology, an incredibly broad portfolio of important science and engineering work. Dr. Prabhakar began her career in 1984 as a U.S. Congressional Fellow in the Office of Technology Assessment. Joining DARPA in 1986 as a program manager, she initiated and managed programs in advanced semiconductor technology and flexible manufacturing and demonstration projects for inserting new semiconductor technologies into military systems. As the founding director of DARPA's Microelectronics Technology Office, she oversaw work in optoelectronics, infrared imaging, and nanoelectronics. In 1993, as a young professional still in her early 30s, President Bill Clinton appointed her director of the National Institute of Standards and Technology, a 3,000-person organization that works with companies across multiple industries to advance science and the standards of scientific research and measurement. Between 1997 and 2011, Dr. Prabhakar held leadership positions at 3 Silicon Valley firms, Raychem, a specialty materials company, Interval Research Corporation, a laboratory for consumer technology, and U.S. Venture Partners, an early-stage venture firm where she worked in clean tech and information technology support. Dr. Prabhakar received her B.S. in electrical engineering from Texas Tech University and her M.S. in EE and her Ph.D. in applied physics from the California Institute of Technology. A fellow of IEEE and a member of the U.S. National Academy of Engineering, she has served on the National Academy Science and Technology Economic Policy Board, the College of Engineering Advisory Board at the University of California, Berkeley, DARPA's Defense Sciences Research Council, and as chair of the Efficiency and Renewables Advisory Committee for the U.S. Department of Energy. Please join me in welcoming Dr. Prabhakar to the podium to address our graduates.
Thank you so much, Dean Helbley. And thanks to Dartmouth, it feels like a great privilege to be asked to continue this tradition that started with Fletcher himself all those years ago, and I'll try very hard to live up to that. So, hello graduating students, hello families, hello friends. Congratulations to every one of you on this incredibly joyful day. And graduates, I'm just so pleased to get to be among the first to welcome you as the newest members of a community. It's a community that designs, that builds, that creates. It's a community that solves, and I'm talking, of course, about the community of engineers. And as one engineer to another, let me just say to you, you're in for an incredible ride. It's going to be an incredible journey. And let me also say, no pressure, but you're joining the club just in time because we've got a lot of problems to deal with and a lot of problems to fix. I think we all know that you're going to be able to go tackle these problems that are out ahead of us because of this very practical, rational, powerful, these elegant ways that you've been learning and practicing here in this exceptional engineering school at Dartmouth. I loved hearing just the sampling of stories as the awards were being made a minute ago, and I know that they just represent a fraction of the experience that you've developed here. And we all know how important that's going to be. Everyone in this room knows how important engineering is going to be to that future, because it's going to be part of getting us as a nation, as a civilization, to the place we need to be. And we know that, of course, because engineering has brought us so much of the world that we live in today. Engineers have designed magnificent skyscrapers that simply shrug when the tectonic plates beneath them shift and lurch. And engineers have been able to design airplanes weighing 1 million pounds or more that can leap into the sky and cross oceans. We've built the infrastructures that allow us to get water with the twist of a tap, electricity with the flip of a switch, and any episode you would like of the Game of Thrones with just the swipe of a finger. So that's pretty awesome, but engineering's actually gone beyond even those kinds of utilitarian needs. Engineering has helped us to launch probes that have traveled to Mars, to Pluto, beyond even that, out of the solar system. We've been able to see past clusters of stars and galaxies all the way to the end of our universe, back to the beginning of time itself. So we know there's so much that we have done and so much we can do with the power of engineering, not just to fulfill our practical and our physical needs, but also to understand our universe, to understand ourselves, and to advance the cause of human progress. But now, let me take note of the other side of the equation, because you all know there's always another side of the equation, right? And the other side of great power is great responsibility. Everything that we do as engineers, every benefit that we bring, carries a potential risk with it, a potential cost. And as our power as engineers grows, those potential risks and costs grow too. And it's not like those are someone else's problems. It's not like we will build it and they will come and then they can clean up the mess afterwards. These are going to be our issues to wrangle with, along with the rest of society. So let me give you some examples. One example, of course, is happening today. We heard some examples of it. We engineers are wrangling vast volumes of data, and that's why today we have algorithms that read our posts and our calendars and look at our purchases. They can predict what you might want to be buying next, or where you're going to travel, or maybe who you should be dating. They go beyond that. They can assess my sentiments, who I might vote for, whether I'm inciting jihad. Every one of these insights that these kinds of data give us, every one of these insights can be incredibly valuable for marketing, for security. But what does all of this mean for a cherished American value, the value of privacy? If we know that our contrail of data or our company's contrail of data, is constantly being watched. Will we be willing to experiment? Will we be open to new ideas? Will we take the risk of thinking up a crazy idea? This has to happen for creativity to flourish. Some of you are going to be tapping into vast volumes of data in the work that you're going to be doing ahead. How are you going to resolve the natural tension that exists today between big data and all the benefits it can bring and good old-fashioned privacy? And classifying online data so that you can serve up the next ad or try to stop a terrorist, that's actually only one of the ways today that engineers are using artificial intelligence and machine learning. AI and machine learning are also starting to be used to control systems. And again, here, the possibilities are endless. Imagine hundreds of times more data through a fixed frequency band because machine learning embedded in radios can predict where the unused portions in that band are going to be from one instant to the next. Imagine machine intelligence in networks that can automatically detect and stop a cyber attack. Imagine artificial intelligence that powers autonomous physical systems. And there are going to be some hard choices here, too. I work in the Defense Department. In our work, we grapple daily with questions about whether and when to grant certain degrees of autonomy to weapon systems. Think about a missile defense system on a ship. It has to be able to act instantly if it's going to be able to protect the hundreds of sailors on board that ship. And that's not actually the only place that we make those kinds of choices about what kind of power to grant our machines. Think about what's happening today with self-driving cars. I think we're going to be seeing them in our streets very soon. Those machines, too, will sometimes have to make extremely difficult life or death decisions instantaneously. How are you going to decide how much and when to trust machine intelligence? How are you going to decide what it can and can't do? How are you going to decide how much power to delegate to our machines as we and our machines become increasingly intertwined? And speaking of becoming intertwined, let me give you a third example. We engineers, in collaboration with neuroscientists, are making unprecedented strides in understanding the intent, the meaning of the neural signals from our brain. And it's a two-way street, so we're also learning how to create neurological signals that we can put into the brain that the brain can understand. These advances can be transformative for our wounded warriors who will be able to reach with just their thoughts and use prosthetic arms and hands and be able to sense the world through those arms in a way that they haven't since they lost their limbs. These technologies can be transformative as well for our warfighters and for others who suffer from traumatic brain injury because these technologies hold the promise to help them with the restoration of memory functions that can be lost with TBI. But beyond just restoration, neurotechnologies could help accelerate learning by inducing neuroplasticity in the brain. Wouldn't that have been helpful these last few years? Think about what kind of a game changer that would be. Imagine being able to absorb, sponge up a new language the way a 5-year-old does. It's great to think about this, but some of the choices ahead are they're really significant here. Where will you draw the line as we move from restoration of function to augmentation? We're okay with braces, with laser eye surgery, with pacemakers. Is a memory-enhancing brain chip different? How will you consider what's appropriate in a future of cyborg possibilities? These are difficult questions, and as we gain even more power to harness matter and energy and information, more of these difficult questions will come. Which is to say, with graduation, you are inheriting and committing yourselves to professional responsibilities that are significant, that are profound. Okay, so why am I talking about all this heavy stuff when we're here to celebrate your graduation and all the exciting things that are coming ahead? My husband's here. I'm a little worried we're going to go home and our daughters will say, well, how did the talk go at Dartmouth? And we'll say, I don't know. They were all sitting here looking at me like this. So the reason that I'm talking about all of this, all of these mind benders, is this. It is precisely quandaries like this that can bring you the deepest satisfaction and the greatest joy in your work that lies ahead. I can tell you that my most gratifying days, my most joyful days, are the days when my colleagues and I are wrestling with these kinds of questions, because those are the days that we know we are truly at the frontier, that we're in position to see a new chapter of human progress. Nothing is more rewarding than wading into this sublimely rich intersection of technology and humanity, shaping its contours and dimensions, and bringing to that process the very best instincts we each can offer about how to make the world a better and a stronger place. More technically empowered, but at the same time, more beautiful, more simply human than ever before. So please revel in this opportunity and the responsibility that you have earned. Take pleasure in the challenges ahead and infuse your work with optimism and exuberance. I can't wait to see the world you're going to create. Thank you very much.